Hello everyone. In this video basically we will learn about the lexical environment of JavaScript, the global object, and we'll also learn about why JavaScript can provide you some features like function hoisting, that is calling the function even before declaring it, and why named function expressions are much different than what is a simple function declaration. So there are a few things that we're going to learn today. And first of all, let's come to what lexical environment is. So lexical environment is basically a context that is given to the script file. Is the context to the script file. So what it does is basically it creates a global object, and it is very theoretical. So it's something which you cannot use. You cannot use it something like, if I go here and if I type window dot foo, I'll get it. But in the lexical environment, you cannot do something like this, lexical environment, and you won't be able to find foo with this, because lexical environment does not exist as something called an object, a real object. It is theoretical. It is described in the documentation of the language as well, and it is used to design the language. So everything that is here, that is declared here, is actually part of that environment. So how lexical environment works? So first let me comment it out a bit to learn what lexical environment does. So first of all, what lexical environment does is it goes to the first phase. It has its first phase when the objects are not even initialized. First phase when the objects are not initialized, or when any element is not initialized. What I mean is, lexical environment says that I know that there is something called foo, but it is not yet given a reference, or there is something like let x or let's see. So this lexical environment knows that there is something called c, but it does not have a reference to it. So this time, for this time being, until unless the variable or the function is declared, it is known to be in a phase. It is known to be in a phase which is basically the dead zone, or the uninitialized phase, which is called the uninitialized phase of the language, of the variable, the uninitialized phase. So let me just type like this. So it is basically in the uninitialized phase at first, and then when you do something like this, the object or the variable gets a reference, and this time it is called initialized. At this time it is called initialized or declared, or whatever you want to call it. But for the functions, function have, or whenever you do something like this, or even named expressions like this, functions basically get the lexical context at the time of declaration only. So when you do something like this at this time, or at, yes, of course, at this time, the lexical environment does something like this. It knows that there is function foo, there is a function foo, and it is declared, or it is initialized. So they are called immediate declaration or immediate initialization, and it goes to the lexical context in the very first phase only. The lexical environment scans the whole code, and it first searches for the function definitions, and it provides them the lexical environment context. The second thing is that this feature helps you to hoist a function. That is, you can declare it even before the function is not declared. Why it helps you to do so? Because lexical environment creates a context, global context. That global context knows that there is something like foo, so it won't throw an error. In other programming languages like C or C++ or Java, until unless you have declared, or even until unless you have declared a function, even not defined it but declared it, then only you can use it to define it or to call it. But in JavaScript, because of this lexical environment context, the foo or any function can be called even before declaration or definition. The next part is why named function expressions are very different and why are they useful sometimes. So basically what named functions will do to us is very simple. We come here and just run it. Okay, what it does for now is I'm just saying you, this is a function definition which takes a parameter called username. If username is not null, it will pass it through this context, and if it is null, it will again pass the function with this parameter Sameep. So ultimately, if you have not passed in anything, you will get name Sameep, and if you have passed something, it will give you name plus that name that you have given. It will do so. But here comes the interesting part. In the next line, we have used function as values, and we have actually copied the function definition of foo to another function called foo2. So basically for now, foo2 does have the function definition of foo. But when you come to this line, what lexical context would do is lexical environment context would erase the definition of foo. It will erase the definition of foo as whole. So now lexical context does not know that foo is a function. It will treat foo as null. Foo is treated as null basically now. And then we try to call foo2. When we try to call foo2, it will basically go in here. If username is not null, if username is not null, it will pass this. If it is null, it will come to here. And in this line, we have written foo. Now lexical environment does not know what is foo because it is not a function to it. It's null, and therefore it will throw an error. So what error it will throw? It will say that foo is not a function. But if you need to pass at something like this, like if now I pass Sameep, remember this is small s Sameep. If I just clear the terminal and then I pass it again, I'll get the name. Why I'm getting this, the second is coming from this. So if now I show you, you can see that this is running because the program is getting terminated here. It is not executing the else part, and this else part contains a foo call, but foo is null. That's why it would give you error. What happens with named function expressions is that you can do something like this. So herein there is a named function expression, which is new foo is the main function name, and fun is the alias of this name. So new foo, so this new foo function is equal to this fun function, but inside the function definition only, and not anywhere else. So this fun is defined between this block of code. If we try to access something like this, we'll get an error. You cannot execute this because fun does not exist outside this function. So what helps you to do so is that it terminates, or it basically does not uses this new foo here. And whenever you copy something like this, new foo and greet, these are equated. So this is new foo is assigned to greet. So greet will get the same function definition from here to here, and then it will run the function with whatever parameter that you pass. If you have not passed any parameter, it will come here. It will execute fun. When you try to execute fun Sameep, remember new foo is null. The alias of new foo is not null. Why? Because greet makes it to existence. What I'm trying to say is that Control Z, Control C. Now what I'm trying to say is that if we delete it, we paste it, something like this. So what greet does is, greet just copies the same function definition, and here fun is again alive. Fun would die between these block of codes, and fun would be alive between these block of codes. So here fun would not have any context, here fun would have not any context, or outside any out of these two functions it would have no context, but here it does have a context. So that's why named functions, function expressions are very important when you are trying to execute a function which is subject to change. Here new foo is a subject to change. Sometimes we do change function to something else as well, like an object or something like an array. We do change in development, but rarely, but it does happen. So in those cases, the functions which are subject to change, we can use named function expressions. In short, it is called NFEs. And what it does help you, it helps you to do something like this. You can call a function, and we can call that function inside that function with using another reference to it, like an alias, and here it is fun. But that alias does not exist outside that function definition. Remember that. The next important part is that sometimes we can also have anonymous functions as well. Like you can do something like this as well. You may omit the need of this fun as well. Then also it would run. The error is because of declaration of two new foo, I guess. Yes. So this is an anonymous named function. It does not have an alias, so you cannot do something like fun over here. You cannot do this. Fun does not exist, but you can surely make it an anonymous named function expression. But here, then this won't work as well. So if I go here, and if I just comment out everything else, if I just run this block of code, I'll get an error as well. An error in the sense that greet becomes null. Okay, so greet becomes null here. If I call it, I'm not getting an error. Okay. Problem is with this context here, I guess. Okay, the problem is with Sameep here. Sorry, the problem is with Sameep. So if I do something like new foo, and then I can get an error. So now it will generate new foo is not a function. The same reason why it did not run this line of code. So basically, when you call a function, the execution context is created for that function, and then the execution context would search the definition of that function in the lexical context. The lexical context would contain this if the function is not null, but here we have declared it as null again. So the lexical context would think that new foo is null, and since new foo is null, this line of code should not be present. What you could do is basically run the function with some other thing, like just copy this line of code, Control C to achieve the same thing. What you would do is Control V and just type in here Sameep. So you would get no errors. Like this, you would get no error. But not all the time we need to do so. We wanted to do something by design, as we wanted to call new foo again here, and we could achieve that with named function expressions by using the alias of that function. And remember that alias is only accessible when it is inside written in the block of code. It cannot be accessed outside it. So summarizing it, lexical environment is basically the global context given to everything that is written inside the JavaScript file. Second, when you declare a function, it instantaneously gets into the lexical environment context, and when you call that function, basically an execution context is created. That execution context searches for the definition of that function in the lexical environment. If it gets the definition, it will execute it. If it does not get, it will throw you an error that the function that you wanted is not a function, it is null. Like here, we have declared it null, or if you would have declared it as object, it would say it is object. So this is basically where the named function expressions overpower the functions. Remember, you cannot do hoisting using arrow functions. You cannot declare you cannot call a function if it's an arrow function before its declaration. So if it would have been an arrow function, you cannot call it here. You needed to call it after the definition only. So there are some things that JavaScript do which is very flexible to the user or to the programmer, and sometimes it's very confusing as well. A lot of times we would have thought that create should run as we expected, but create could not run because it was null. Remember that null was written after copying as well. Then also it could not execute it because here we have hard coded it, and here we have given the flexibility to use the alias of the function. That helps. Okay, so that's it for now. Thank you so much.